Okay, so let's take a look at this 3.3, the inverse of a quadratic function. So we've taken inverses of things before, and we know that inverses is inverting your x's and your y values, or inverting your domain and range, interchanging them. So it says here, key concepts, the inverse of a quadratic function can be found by interchanging the x and the y in the vertex form and then solving for y. So it's very important you understand when you take the inverse of a quadratic function, it must be in vertex form or you will not be able to do it. So you can try that and you'll see what the problem is, but it has to be in vertex form. I would highlight that and then solve for y. And then it says, number 2, the inverse of a quadratic function is a parabolic relation that opens to the left or to the right. If the original function opens up, the inverse will open right. If the original function opens down, the inverse will open left. So we'll see why that happens. It's very important to note again that the inverse is the reflection on the y equals x axis, or the y equals x line. Okay, because all your x's become y's, all your y's become x's. Number 3, the inverse of a quadratic function has a positive and negative square root value. The positive root represents the upper branch of the parabola, and the negative root represents the lower branch of the parabola. We spoke about that when we were talking about the square root function and how to graph the square root function. If there was nothing in front of the square root function, it just wanted the positive stuff. If there was a negative, it just wanted the negative stuff. If there was both positive and negative, then it wanted both positive and negative stuff. Then it says, number 4, the inverse of a quadratic function is not a function itself unless the domain of the original function is restricted. So we'll get to that and what that means. But a parabola, if you take the inverse of a parabola, it is never a function because it's going to be a parabolic shape that opens sideways unless the restrictions, unless you restrict the domain. So let's take a look at example 1. It says, A, given f of x equals x squared, or y equals x squared, graph the inverse. So here is y equals x squared. Now, we can come up with the table of values for y equals x squared, of course. And y equals x squared, since it is in blue, we have the point -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. I'm just reading these points off here, 0, 0, -1, 1, -2, 4, and so forth. That is y equals x squared. If I want the inverse of this, so if I want the inverse of this, then I would just simply invert these points. I have points already, the original points. Invert these points. The inverse of -3, 9 is 9, -3. The inverse of -2, 4 is 4, 2. -1, 1 is 1, -1. 0, 0 becomes 0, 0. 1, 1 becomes 1, 1. 2, 4 becomes 4, 2. And 3, 9 becomes 9, 3. So interchanging your x's and your y's. Now if I go to graph this, I have 9, -3, which is not even on our graph. 4, 2, so 4, 2 right here. 1, -1, which is right there. 0, 0. I have 1, 1. I have 4, 2. 4, -2. Sorry. And so if I graph this, it's going to look like a graph like that. A parabola, a parabolic shape opening sideways. Again, it's very important to note that this line right here is your mirror. This line right here is y equals x. And that's your mirror. Whatever's on that side of the mirror is now on this side. Whatever's on this side is now on that side. So it's just interchanging your x's and your y's, or it's a reflection in the y equals x axis. So that becomes a parabolic shape opening to the right. Again, parabola opening up, take the inverse, it's a parabolic shape opening to the right. Now, then it asks us in question B to determine the equation of the inverse. So if we want to come up with the equation of the inverse, remember, in order to come up with the equation of the inverse, it must be in vertex form. This is in vertex form. It's the most basic parabola. The first thing I'm going to do, write x's and y's only. Okay? So I have x's and y's only. Then, taking the inverse of this thing, in order to take the inverse, you are inverting your x's and your y's. So wherever you see a y, you write an x. Wherever you see an x, you write a y. And then you go to solve, so that's step one, and then you go to solve for y. So in order to solve for y here, I have to isolate for y. I have to take the square root of both sides. Now remember, just on a little important note here, if you are personally taking the square root of 9, just remember the square root of 9 is 3, because 3 times itself is 9. But the square root of 9 is also negative 3, because negative 3 times negative 3 is also 9. So when you take the square root of 9, it is actually plus or minus 3. So it's very important you remember that. And of course in your quadratic formula, that's why you have plus and minus in front of the square root sign. So taking the square root of both sides, that cancels out the square. So y equals plus or minus the square root of x. Now this should make a little sense to you, because you know what y equals square root of x looks like. It looks something like this. Half of a parabola opening sideways, the positive stuff. The negative stuff will be this part here. So this is y equals plus or minus the square root of x. So we discussed this before, and of course you can come up with the domain and range of that if it asks for it.